Hello and welcome to today's audio technology webinar. It's been a while since we've had one of these, but it's nice to be back again. Topic today is digital microphones. My name's James Waldron. I'm the product manager at Sennheiser for microphones, wireless mics, and also for wired microphones. And my pleasure to bring you a little fireside chat about digital microphones, how they work, what they do, and why they're a good idea. Digital microphones. So digital microphones might sound a little bit like an oxymoron. You might think, digital microphone? How's that? Surely sound is an analog phenomenon, yeah? So what's with a digital microphone? Well, let's have a little look here. Of course, sound in the air is an analog phenomenon. In fact, I've no idea how they did this little picture, but you can clearly see waves in the air, analog sound. A digital microphone is actually, or it starts with an analog microphone capsule. So you can see in the little picture here, just a classic condenser capsule. So it's a microphone capsule capturing analog sound out of the air, turning it into an analog signal. The secret to the digital microphone is that built into the microphone device itself, there is a preamp and then an analog to digital converter. And so out of this digital microphone comes a stream of digits, a digital representation of the analog sound wave at the beginning. So what your digital microphone is doing is converting an analog sound into a digital audio bit stream that we can then process as we want with all the advantages of digital audio. So that's great. Why do we want a digital microphone, you might ask? What's wrong with an analog one? Well, look, the reality is there's not much wrong with an analog microphone. In fact, a digital microphone incorporates an analog microphone as a part of it. The benefits for digital microphones really come from the interface between the microphone capsule itself and the subsequent devices, the mixer or recorder or whatever your other devices are that take and process that signal. So it's the interface where we can really make some differences by having a digital signal coming out of the microphone. So, like what? What's going to happen? What's going to be better? Well, the answer comes from the ability to completely design that whole interface into one device. So the designer has control of a whole lot of things. He can match the mic capsule output into the mic preamp parameters. You can ensure signal integrity on long cable runs. You can minimize the impact of any interference on long cable runs. And because you now have digital communications between the mic and the subsequent device, it opens up the potential to communicate with the microphone and make some adjustments to the performance of the microphone remotely. So that's a pretty funky thing to be able to do as well. And of course, not only is the preamp built into the mic, but so is the A to D. And because the system designer has a good understanding of the performance of the mic capsule itself and of the preamp, they can then make sure that the design parameters for the A to D converter are perfectly matched into the preamp and the mic capsule, so that now you have a perfectly aligned, if you like, or harmonized system. The mic capsule, the preamp, and the A to D converter are all there, joined into one system, designed to work harmoniously together. So there are the benefits. Let's have a look at some of these in a little bit more detail. So you're probably aware different microphones have different sensitivities. Some condenser mics, for example, will spit out 40 millivolts per Pascal, so quite high output, quite hot mics. Some of the classic dynamic mics, like the old MD421s and so on, quite low outputs, 2-3 millivolts per Pascal. So you've got a ratio of 20:1 there, straight away. If you're designing a mic preamp as a separate device, then you have your challenges in how do I make sure my mic preamp can do the best job for these high output mics where maximum output level can be a couple of volts even, versus these low output dynamic mics where I'm really dealing with really tiny signals. So it's not an easy job if you're designing a mic preamp that has to cope with a wide variety of different mics. Job's a lot easier and you have to make less compromises if you can design a mic preamp to work with one style of capsule or one set of capsule parameters. Again, dynamic range capabilities in different mics. So some mics have an enormous dynamic range that they can deal with, some less so. If you can match, again, your parameters for preamp design to the capsule, so much the better. One of the other points is that different microphones have different output impedances. And while on a brochure or a spec sheet it'll say whatever it is, 50 ohms or 100 ohms or so many ohms, the fact is that it won't be that impedance at every frequency. There'll be a curve that relates to that. And for a microphone with an electronic balanced output, such as some of the modern condenser mics and so on, it's an electronic output stage, output impedance fairly solid, not too bad. When you get to transformer output mics, so some of the older classic mics with the transformers, or even a dynamic mic, the output impedance is actually quite a complex mix of resistance, capacitance, and inductance. And all of those things together interact with the cable and the input impedance of your mic preamp. If your mic preamp has input transformers, then again, you've got a complex impedance, which consists again of inductance, capacitance, and resistance. So all of those things, particularly where there are complex impedances involved, can certainly impact the transient response, phase response, and frequency response of your mic. So if you can get away from that mixture of impedances and potentials for mismatch, so much the better. How about long cable runs? Well, the longer the cable run, the more opportunity you have for those complex impedances to have an impact. So typically you'll see gentle roll-off in frequencies, particularly high frequencies, and there is also the potential there for resonances, not necessarily in the audio bandwidth either. So you might find that there are resonances up in super high audio frequencies, in tens of kilohertz, or even in RF areas as well. So longer cable runs just give you more potential for issues to arise. Likewise for induced noise. Obviously, the longer the cable run, the more potential there is for induced noise. Of course, most mic runs are balanced, but there's also always a slight impedance or a slight unbalancing of the cable. The longer that is, the greater the potential for that unbalance to be. And of course, the longer the cable run, the greater its exposure is to external magnetic fields. And so the greater the influence of external signals, such as noise on power lines or lighting circuits or dimmer circuits or all those kinds of things. They really can have an impact and get into your audio. And if you're running tiny little mic signals down a long, long wire, the opportunity for noise is there. And I'm sure if you've used mics, particularly low output dynamics, over long cable runs, I'm sure you will have seen or at least heard the impact that you can have on long cable runs. Sometimes those noises won't necessarily be in the audio range, but they can upset the performance of the mic preamp so that suddenly you've got weird things going on with your mic preamp. They don't sort of sound like audio, but you know it doesn't sound right. So that can have to do with RF interference, upsetting the way that the preamp operates, or sometimes big common mode signals can get in the way too. So all kinds of things over long mic runs can be an issue for you. So again, if you can get rid of those, so much the better. The third one was remote control of the mic. What? So I can't reach a microphone to do something, adjust it or whatever? Well, consider a concert hall with installed microphones. So there's a picture of one here. Some of you may have even seen this concert hall before. It's the concert hall in the Sydney Opera House. They have a number of microphones installed there. They hang on winches for concert recordings. And as you're probably aware, Sydney Opera House has lots and lots and lots of different types of acts that come through there. So different gain structures, different patterns and so on are sometimes called for. So the ability to change the mic parameters for sensitivity or compressor limiter or those kinds of things could be really handy in that kind of environment. On stage during the show, performances vary. Live performance isn't the same as it was in rehearsal, or tonight's a really good crowd, or who knows what's going on. You need to make some changes to it. You can do that remotely. You don't need some guy running up on stage trying to get into the drum kit to change some mics around. So it's a useful and flexible feature. And again, remote mics, if you're out on sports coverage or so on, the ability to change the parameters around the mic, very, very useful. Okay, so there's some useful functions and useful features related to digital mics that you can't really do with analog mics. What else could be improved? Well, the mic preamp, of course, adds coloration, distortion, and noise. Not lots of it. Well, the good ones don't. And this, of course, is a bit of a double-edged sword. Double edge, of course, on a sword is a very good thing if you're fighting people, because it cuts both ways. And indeed, it's the same for mic preamps. Noise, distortion, coloration, cuts both ways. So it's not necessarily a good thing. The purists don't really like coloration or noise. They want the cleanest, quietest, zero coloration that they possibly can with a mic preamp. But of course, there's the other people who are using mics and preamps as a means of painting with sound, if you like. So the coloration and the tonal qualities and so on really do become a part of generating that sound. So, some people like the qualities of a mic preamp. Some people are always trying to get away from the qualities of a mic preamp. So when you go to digital mics, of course, the purists give it a tick. Lovely, very good. So maybe that's the wrong sort of tick. That tick, that's the one. And the people who use coloration and noise as part of their sound, yeah, well, you might think they'd see it as digital mic, no sound, no particular sound, really quiet, no coloration. You might think, they're not going to like it. But you know what? Most of the people that I talk to today go, yeah, doesn't matter. I just use plugins. So that's all good. So that really covers that. Plugins, from a lot of people, is the way that they're able to generate the sound of different mic preamps without actually making the investment in the hardware in the studio. So having a mic preamp that is really quiet, clean, no particular personality, can be a really good thing. Okay, so there's not a lot of manufacturers of digital mics. I think there's three actually: Sennheiser, Neumann and Schoeps are the people who are making a digital microphone of some sort. There are standards in place, which is a good thing because it means they're kind of interoperable, really. Standard is called AES 42. It started in 2001. I think Bayer actually made the first digital mic in about 1999, and then there was some discussion amongst various manufacturers about why didn't you do it like this, and as you can imagine. So a standards body was formed. They came up with the standard called AES 42. The first version came out 2001, and it was revised in 2010, the latest revision anyway. The standard is essentially the AES3 bit stream that we all know and love and that we use every day. The AES signal that goes down the XLR connectors. That's what this is based on. And the bit stream is basically that. It's 24 bits. This standard can accommodate sample rates up to 384 kilohertz. So it's pretty much future-proof. It can accommodate mono or stereo. It has facilities to allow a test generator to be built into the mic, so you can do all your gain setting and whatever pretty easily, remotely, without having somebody sitting on a guitar or banging away on a drum for hours at a time. You can at least set up your gains. Pretty straightforward. There is a facility within the standard for compressor, limiter and de-esser. So we'll talk a little bit more about that in a minute. Mic ID, so the mic tells you what sort of mic it is. There's phase reverse. You can also put a channel name in here, so there's a little area where you can write your detail, like a little scratch pad, I guess, is accommodated within the standard. The ability to change mic patterns for multi-pattern mics, you can do all that remotely. You can adjust the gain if you want to, and when you're operating in stereo, you can also change the pan and balance. So lots and lots of stuff happens within the standard. There are two modes of operation, of course. Once you start looking into the world of digital audio, people start going, word clock, sync, can I free run, da-da-da. Well, yes, you can. AES42 will find lots of, or has found lots of application in location recording and so on. So in those sort of cases, it's not unusual to just free run into your recorder. So mode 1 is a free running mode. So you can just set up your mic into your recorder, away you go. If you're running multiple mics, you may find you need a sample rate converter in there, but that's a very simple way to operate. Mode 2 is where you run the devices with external word clock, and then now you're syncing your mics into a bigger system, and away you go. So the mics have the capability to run to an external word clock and be sync locked in that way. And the user interface does give you that indication as to where your sync is coming from on each mic. I should just point out, just going back to that previous slide, that little diagram there is the control panel in one of the Neumann digital mic interfaces. And so it does show you most of the functionality that is available in the AES42 standard. So I don't know, hopefully you can see my little mouse up the top there. Is that right, George?
Yep.
Yep, excellent. So my little mouse is showing you the type of mic that's being returned from the microphone into the system. So it's telling me that's a Neumann TLM103D. It's telling me it's currently set up for cardioid pattern. I have a low cut filter that's available here. At the moment it's set for 40 Hertz. There is some pre-attenuation and some gain, again, that I can set here. I can turn on my test signal. In the Neumann's case, it's either a tone at various levels or pink noise or white noise. It shows me what the word clock is here, what the signal is for word clock. Then I have a little section here for the compressor and limiter. It shows me the compression ratio, the threshold, and attack and release times. They're all adjustable. And you'll notice also that there's a little filter here for flat 1K, 2K, or 4K. This is a de-essing function so that the compressor limiter only works on frequencies above that corner frequency that you set here. So if you leave it at flat, obviously it works as a compressor limiter. If you put in a corner frequency and it only operates on the frequencies above there, then it acts as a de-esser. And obviously you can adjust your compression ratio and your thresholds accordingly for the best impact there. If you wish to. You don't have to use any of this, of course. There is a peak limiter in here which you can set up just so that if you do suddenly find that you're running out of headroom, at least it doesn't just crash. You've got a peak limiter there to smooth off those peaks. And then down the bottom here, there's a microphone mute, there's a phase shift, and there's red and blue are labelled here. So you can actually turn on a couple of indicator lights on the mic if you wish to. That might help the talent understand which mic is live, which one's not. It might help you identify which mic it is, so you can press the button here and go, oh, that's that one over there. If you've got a dozen set around a stage, you can pretty quickly figure out which mic it is. So red and blue lights just help you identify the mics. You can use those for whatever purposes you might want to. And there's also buttons here to give you some system information and a little scratch pad down the bottom. So plenty of information in that user interface should you want it, and that's all done in the microphone remotely. Okay, moving right along, let's have a look at how this works. So we talked earlier, right at the beginning, about the concept here. This is a Sennheiser MKH8000 series. So you have the microphone up here, which is a standard MKH8000 microphone in our case, but This is the concept. So a microphone capsule here delivering an analog signal into the preamp and A to D converter. The connector here is just a 3-pin XLR, so it's just like an ordinary microphone. It runs down a balanced cable, and we might talk about that a little bit later in detail. But inside the cable, there is the AES bitstream data going from the mic down to the control device. There are the mic details data, so that tells you the model number and serial number of the mic. That also is going down to your control interface. And then there's 2 lots of signals coming back. So control signals back to the mic, so adjust the gain, do this, do that, whatever it is you want to do. And there is also, of course, the thing doesn't run on thin air or the smell of an oily rag. You need some phantom power for that. So there's 10 volts of phantom power that is specified as part of the AES42 standard as well. So all of that information is going up a pair of wires in the microphone cable. Now the standard says that the microphone cable you should use is a 110 ohm balanced cable. So it looks like a mic cable, feels like a mic cable, but the spec is a little bit different. 110 ohms is the native impedance of this digital system, and it's part of the spec. What you'll find is that in order to maximise the performance of the system, you should use 110 ohm cable. What you'll find in reality is that mic cable works pretty well, particularly if you're using a good one, a Megami or a Conair or a Belden or one of those premium cables. It'll work pretty well, but you can't be sure that it'll guarantee performance over the specified length, which is about 100 metres from memory. So if you want to be certain of your performance, 110 ohm cable is the way to go, but most people find that a good quality mic cable works pretty well. I'm sure I'll probably get some questions about that later on. Okay, so good-o. We've seen what's there with the mic and the connectors. What am I going to plug it into? Because I can't plug it into an analog mic input, obviously. What do I plug it into? Well, look, there's a few different devices that have a direct AES42 input. I had a quick squiz on the web just before we did this. Nagra have a nice portable recorder called a Nagra 7. Has AES42 available for it. If you're looking for a PCI card, there's a thing called a Trace AES42-4, which also can accommodate AES42 inputs. A Digico SD rack here in the middle, input area for their consoles. They have an AES42 card input as an option. The Zaxcom company apparently has some wireless transmitters that can accept AES42. So that's an interesting little development. Sound Devices 788T, of course, location device for location recorders. Very popular high quality device. AES42 option for there as well. And RME, famous for making studio interfaces and so on, they have a thing called a DMC 842. That's an 8-channel digital mic interface. So there are some of the devices that you can use straight away for plugging your digital mics in. Other devices, there's a couple of products from Neumann and Schoeps. Schoeps have some fairly straightforward interfaces, and they really are just a hardware interface as such. So the little products down here on the right, one of them is effectively just a powering device. So the little box you can see in the bottom right hand corner takes an external power supply, powers the mic and converts it into just a standard AES signal that you can pop into an ordinary AES input. Or the other one there with the cables has a built-in D to A converter, so that you can plug your digital mic into that and it spits out standard balanced audio. Again, both of those boxes need an external power supply. Then a little more familiar to me are the Neumann DMI2 Portable and the DMI8. These are interfaces that incorporate computer control of the mic as well. So apart from having the ability to connect your digital mic straight into here and spit out some AES audio, they also have the ability to deliver the remote control signals from a computer interface. So the software comes with the mic and loads up into a PC or a Mac and gives you that user interface that I showed you before. So these two are very useful interfaces that'll bring you out into digital audio world for all sorts of other purposes. Let's have a look at what's on the back of those two boxes, because this is easy for me. On the DMI 8, it obviously needs an external power supply, in this case 240 volts. Well, it's universal power supply, so AC mains essentially. If I just walk across the back of the panel here, there's a control bus here. You'll notice they look like Ethernet connectors, but they're not. They're RS485, so you get a little dongle to connect into your laptop, and RS485 is the connection there to your laptop. There are two multi-pin outputs here, so these both carry 8 channels of AES audio, one in the Yamaha pinout and one in the Tascam pinout. So I just try to take care of both eventualities there. You'll notice up here there's a little blank panel. We have options for things like MADI and also for Dante as optional outputs for this particular box. There are word clock input and output connectors here on B&C, standard word clock, and your 8 AES42 inputs on standard XLRs. Okay, so you plug your digital mics in here, and the standard digital AES3 comes out on the Yamaha or Tascam multi-pins. There is an extension port here, so you can link multiple boxes together to generate 8, 16, 24, 32 channels together. And the other funky thing over here, sat in the corner, is the ADAT optical output, so that'll provide 8 channels in the ADAT format. So that's the DMI 8 box. The DMI 2 portable is a much less ambitious kind of box. It's just for 2 channels. So you can plug in one or two digital mics here, and it comes out as an AES EBU stereo pair. On the other side, you have word clock through and in, and external power supply, and then a USB socket here to connect to your laptop. So again, you have control of your mics. So quite a useful little box. Okay, so that gives us a little bit of an insight into controllability and functionality of what's possible. In terms of the mics that are available, I've mentioned the Schoeps brand before. Very nice quality mics, German made, long reputation for quality. They have this product. This is, I think this is their only digital mic product. It's called the Super CMIT2 digital shotgun. It has 2 capsules in it. One is your standard shotgun, and then the second capsule you can put into circuit or take it out. It's quite flexible to give you much broader reach. Much broader reach, that's not right. Much longer reach with a minimal lobe at the back. So pretty flexible little mic there in the digital AES42 format. And then Sennheiser and Neumann have a bit of a suite of digital microphones each. And there are some key differences here. So this graphic shows in the middle the 2 interfaces, DMI 8 and DMI 2, along with the software channel strip. On the left-hand side of the image, a couple of mics up the top, TLM 103D and the D01. These are complete integrated solid AES microphones. Okay, so the preamp and the A to D converter are built inside there. The XLR connector you can see on the bottom spits out AES42 digital audio signals. Then below that you have the KMD 100 series. So this is a modular range of mics developed by Neumann to take advantage of a range of mic capsules. So there's a range of little capsules available in Omni, cardioid, supercardioid, figure 8, etc., etc. And then there is basically the body of the mic that incorporates the preamp and the A to D converter. So that can build you a nice suite of different microphones with a smaller number of bodies and a good range of capsules for flexibility for all kinds of different applications. On the Sennheiser side of things, the MKH 8000 series of mics take a similar concept to Neumann in that there are a range of capsules, MKH 8020, 8040, 8050, 8060 and 8070, so they go from Omni through to a very long shotgun. And then the MZD 8000 is the A to D preamp and A to D converter, and it basically just screws onto the bottom of the mic heads and is able to spit out your AES42 signal. The interesting thing with the Sennheiser converter is that it's a stereo converter. So you are able to, through the use of an adapter cable, you can plug on a stereo pair of mics. For example, you could have a cross pair of 8040 cardioids or a pair of Omni capsules. Take a little Y cable into that converter, and now you have a digital stereo mic, one cable off to your recorder or whatever it is that you're plugging into. Or another option is their MKH800 Twin, which is a lovely large diaphragm condenser mic with two capsules built in, switchable patterns, so that can also plug in quite nicely to the MZD 8000 and give you beautiful stereo mic or switchable pattern mic as well. Other options include the gooseneck mics that you see there as well. So Sennheiser and Neumann both have a bit of a systematic approach to this field and a good range of product. So that gives you a bit of an indication as to the mics that are available. So who's going to do this? Well, people who appreciate or who value the differences between a standard analogue mic and digital mic techniques. So concert halls, we already talked about the Opera House as somewhere where digital mics are quite a worthwhile device to use. It makes life for them very much easier. Film sound recording and ADR. I know that one of the major film houses in New Zealand has a DO1 and another one on order for recording Foley, basically, and Foley and ADR. One of the interesting things I found just in doing some research for this presentation is a guy in the UK called John Willett who runs Circle Sound Services, and he's been using digital mics for ages. He was talking about his introduction to digital mics, and he found it very disconcerting at first because as they were replaying takes, they could never hear the noise that you would typically get from an analogue mic. So takes that they'd done with their digital mic, when you went to replay them, the noise that was just kind of there, almost subliminally in the background from an ordinary mic, wasn't there anymore. And a number of times he'd roll tape, or not roll tape, but roll playback and go, oh, I missed it. And then all of a sudden, you'd hear the take number and go, wow, really quiet. So really significant differences in the performance here, particularly where you have nice, quiet, crisp, and I guess great recording environment. You can really hear the difference in the sound itself. And we're also finding applications into the rock music world. So a couple of people that I know, Dave Worcester is front of house guy who works in the UK. He spent a number of years working for, well, he's currently working for Leona Lewis. He spent a number of years doing front of house for Van Morrison. But today, these days, working with Leona Lewis, most of his mics on stage are digital mics. He has a big kit of Sennheiser and Neumann mics, and that's what he uses on stage. People who come and hear the show and listen to what he's doing are knocked out by what they hear because of the sounds that he can pull from a stage with his digital mics. Another good example is Angus and Julia Stone on their tour that they recently finished. There's a nice story about them and their digital mics that they're using in the June issue of Audio Technology. So I know that the AT boys went and had a chat with the guys who are putting the sound together for Angus and Julia Stone. They employed some digital mics around the drum kit there, just as a bit of a test, I guess, to see how it went. So I have a look at the June issue of Audio Technology magazine, and I think you'll get a bit of a feel for how people think when about the results that they get from the digital mics. So there we go. That's a quick introduction, little fireside chat about digital mics. What else would you like to know? Does anybody have any questions? Perhaps there are some. Here's my friend Dan with some questions. Perhaps.
Perhaps. Well, thanks, James. That was really interesting and very informative.
Thanks,
an area people don't maybe know so much about. There has been a few questions, a few comments. Thank you, thank you everyone for taking part and putting in some questions.
Excellent.
So we had a few different questions. So first of all, this question about mic cables. So it's been commented that it's great you can run these really long cables with no interference, no RF problems, all the rest of it. How long can you go, and also what sort of cable should you use?
Okay, so I'll put on my engineer hat. The sort of cable that you should use is the one that's specified, which is the 110 ohm AES digital audio cable, and that'll give you by far the best performance over long distances. 100 metres, no problem at all. But what we've found is if you do use good quality standard mic cables, you won't have any trouble getting 50 or 75 metres at least out of them. So in theory, and I'll always say, please use the right product for the right job. So I have to put my hat on and go, you know what, 110 ohms, that's the go. In reality, you kind of can get by, but I'd rather you didn't. Okay,
yeah, good advice there from Dan. And I guess another question that came up is around a basic implementation of AES42 versus one which includes control parameters. So if you have a more basic device which accepts AES42, will that always give you access to the control parameters on the mic, whether it be the gain or the polar pattern, or are some of them not able to do that? Well,
Dan, that really depends on how the manufacturer of that device has implemented the AES42 standard. So in the case of something like the RME interface, everything that you could possibly want is implemented there.
Yeah.
In the case of some of the other much simpler boxes, then there's almost no computer interface there at all, and it just delivers however the mic is set up. One of the nice things with the mics is once you set up the parameters, then they stay in the mic memory. So if you've got a job and you're going to a particular venue and you know the artist and it's always the same, you can set the mics up back in the office or in the studio or sitting at home at the kitchen table, and then you don't need the computer or anything. You can just take the mic and plug it into the interface and away you go.
Right.
So it really does depend on how much of the AES42 standard the manufacturer of the device has implemented.
Great. So I guess the message there is then don't just, if it says AES42, that your mic will work, but you should also just check the specs if you want to make sure you can control all the parameters as well. Absolutely.
Have a good look at exactly what it does. And if you know a good reseller and somebody you trust, they'll be able to help you with all of those details.
And how about kind of sampling rates? You talked about the standard goes up to 384, whatever. What about mics you can buy today? What can they do?
Well, all of the mics that you buy today will at least go to 96 kilohertz.
Okay, so you're pretty good to go with.
Pretty good to go with what you want now, 96 kilohertz, and it's all 24 bits. So, yeah, it's pretty good.
Cool. Yeah. Great, I think that's covers pretty much all the questions.
That's all the questions
from the webinar. Yeah,
wow.
You obviously covered it so well.
Hang on. I've got another one, George. So the question is, can we put the Sennheiser MZF 8000 filter module in place? Yes, we can.
Yeah. So we kind of answered it. We kind of asked the question in a slightly different way. But there was another question around the MKH 8060.
Yes.
And when that's obviously plugged into the MZD 8000.
Yes.
Yeah, which is all good. Gives you that great shotgun mic with the digital. You can still you can now control the parameters of that mic via the AES42 interface.
Yes, that's right. The mic itself spits out an analog, like the MKH 8060, the capsule part of it is an analog signal. If you want to, you can put the MZF 8000, which is a filter that rolls out the low end, so you can put that in and then put the MZD 8000 A to D converter on the end of that, and now you have a microphone with the low cut already implemented and control of it through your AES input. Yeah, hopefully that answers your question. If it doesn't, you know where to find us, I'm sure.
Okay, good.
Okay.
That's all. Thanks, James.
Awesome. You're welcome, Dan.
And if you have any more questions or you have any more comments, please continue to stick them in the webinar stream, or you can contact either Sennheiser or Audio Technology via the usual channels, and we will get back to you with answers and information as you need. Way cool. Thanks, Dan. Thanks, everybody, and thanks to AT.
Thanks for coming along and getting involved in our seminar. We look forward to seeing you next time. Cheers for now.